Good afternoon, everybody. Uh, Thank you very much for giving me the opportunity to present a topic that I work on day-to-day basis. I am Professor Kazi Saiful Islam. I am working at Urban and Rural Planning discipline of Khulna University, Bangladesh. It is located at the southwestern part of Bangladesh. Apart from being an academician, I am also working as a professional urban planner and GIS expert in different projects. This provides me an opportunity to gather practical experience from these projects and criticize these projects from my academic perspective. Having said that, the topic that I'll be talking about today is rather broad, and it is almost impossible to cover within 30 minutes. So I'll be presenting some key issues. In no way my today's presentation should be considered comprehensive or critical, because I will cover quite almost major part of urban planning, at least in Bangladesh. My today's presentation is actually divided into 4 parts. The first part of my presentation will be, I'll be talking basically about the determinants of the depth and dimension of GIS application in urban planning. Then I'll be talking about different kinds of data that is used in planning. It will not be a comprehensive list or anything like that, but some of the major typology. Following the data types, I'll be talking also about the technology currently in practice, and also maybe I'll put one slide that will be talking about the future potentials. Once again, it will not be a comprehensive one, but it will give you some perspective, those who are not from the planning field. I'll conclude through identifying some of the gaps between the academia and the current planning practices. So let's talk about the first one, the determinants of GIS application. Planners basically use GIS for various purposes. Here I have identified 4 major ones. For example, descriptive and predictive model. What I meant by descriptive and predictive model is we use GIS to describe existing situation, identify problems, sometimes forecast the future. At the same time, we use different kinds of demand identification. I have already said that model and monitor changes, relationship among the variables, or identify the major determinants of the change, impacts and contingency, etc. One of the most underrated issue that is often overlooked, that is, we use GIS or geospatial technology to communicate with the decision makers. We use it when to collect their thoughts. We use it to describe our thoughts, and it's a whole lot of discussion. We can have a whole day regarding this one to talk about how to use GIS to communicate with the others. We have used GIS to communicate with the rickshaw pullers in Dhaka city. We have used GIS to communicate with the school-going kids. We have used GIS to communicate with the farmers. So each one of these communications have different set of tools, different set of symbology, and we used it in a different way to make it more effective, to make it understandable for the respective community that we want to communicate. As I have already said that application of GIS or geospatial technology in planning basically depends on what kind of planning are we really focusing on. And When we are talking about the planning, it is basically dependent on the planning philosophy and approach. What it means is that based on the existing situation and the future vision, where we want to see a place in the long run, based on these two, we develop a vision of a city or an area. To implement that vision, we need to consider different kinds of things. For example, local context, tradition, tools, like previous planning practices, etc., based on which we identify the planning approach. And planning approach determines what kinds of tools or techniques we need to apply, what kinds of data we need to collect, in which depth and dimension we should really cover, so on and so forth. At the same time, scale plays a very vital role, quite important for planning. When we are planning a small area, we collect as much detailed data as possible. But when we are talking about like couple of hundred square kilometer, the depth and dimension of the data also varies. Then again, the planning has two major divisions. I wouldn't say division, but two parts. One is interdependent on the other one. The first one that we call the substantive planning, and the other one is called procedural planning. Substantive planning means the variables that the planners need to consider to prepare a plan. And the procedural plan basically deals with the substance, analyze it, extract information, and use it for decision making. So substantive planning and procedural planning goes hands in hand. But substantive planning differs from one place to another place significantly. For example, if an area is located in a drought prone area, then we need some variables that is quite different from the area that is earthquake vulnerable, or maybe arsenic prone area. Each one of the area has its own requirement. To satisfy those requirements, we collect different kinds of data, and I will present these things in the next couple of slides. That different plan require different kinds of data, and different data requires different kinds of analysis for decision making. This is one of the figures that I developed for Dhaka detailed area plan. It is one of the biggest and most complicated plans. Here I have just portrayed the different kinds of planning approaches that we adopt depending on the purpose of the planning. For example, if we want to develop a economic zone related plan, then we usually adopt entrepreneurial planning approach. If an area is highly poverty prone, we use transformative planning approach. Rational comprehensive planning approach is basically what we use for land use plan. It is a step-by-step process. Bangladesh and all over the world, this is perhaps the most popular planning approach right at this moment, and I'll be talking mostly about the rational planning approach and overlooking the remaining other kinds of planning. Major types of data. Here in this part, what I am going to do is to describe some major kinds of data that the planners always need for decision making. In no way it is this presentation portrays the comprehensive nature. It's just some kind of data that we often use, not the comprehensive list. First one that we always need is the population and economic related data. We often collect this data from the secondary sources, and sometimes we go for questionnaire surveys. Sometimes we use different kinds of participatory methods, PRA, so to collect these kinds of data. Population size and composition of the population and economy is the major determinant of identifying demands for housing, different kinds of utilities and services, etc. and etc. At the same time, we also need to identify the spatial distribution of population, concentration of population over the space, and also the economic activity. The map that I am showing in this slide basically shows the employment distribution of Joshua-Benapole Corridor project. It is basically the first ever corridor development plan for Bangladesh. Some other such plans are in the pipeline right now, but this is the first one where we used the corridor planning principle for planning the whole corridor. And here the red areas identifies the major concentration of employments or commercial establishment or non-residential establishments. Then the second most important category of data that we collect is and use is the environmental system, topography and slope. Basically, we use topography, collect the topography and slope data while we collect the physical feature survey data. Physical feature survey usually comes from, this data actually comes from nowadays from the photogrammetric analysis, but we also collect it from the field. Sometimes we do collect the rivers and lake related data or water body related data from the secondary sources. We use different kinds of analysis for these kinds of data. I'll be talking about it later. Secondly, soil survey and seismic vulnerability assessment. Basically, soil survey and seismic vulnerability assessment data is relatively new addition in Bangladesh, but it is not at all new compared to the world's perspective or global perspective. We need different kinds of data in this regard. Geological data is there. I'll be talking about it later. But in addition to geological data, we need weight bearing capacity, which is also related to the geological data, shrink swell data, infiltration capacity, erodibility, all these kinds of data we need it. Then we also need data for hydrological modeling. Here I have shown another map that we prepared for the Joshua-Benapole Corridor project, showing the inundation area for different flood return period. Here you can see that for 100 years return periods flood, almost 92.45% area will be flooded for such an incidence. This is another example of flood modeling. Left-hand side, this is actually developed for the eastern part of Dhaka, prepared by Institute of Water Modeling. Left-hand side, it is the digital elevation model, and right-hand side, it is showing the inundation area of if a flood occurred at the extent of 1993. Considering the proposed land use, what would be the scenario of flood? This is very interesting one. I am pretty sure that most of the Bangladeshi audience didn't see the map in the left-hand side. The right-hand side, this map is pretty popular in Bangladesh. It is prepared by GSB, Geological Survey of Bangladesh. This is basically the infrastructure suitability map. It is not at all a very complex map. They just prepared this map using the soil load bearing capacity. But the left-hand side data, the land use suitability map, this is actually prepared for the Rajshahi Development Authority. This map used the multi-criteria analysis and AHP, analytical hierarchical process, where the variables were like peak ground acceleration, foundation layer depth, soil type, liquefaction potential index, building height recommendation, etc. Considering all these variables using AHP, they developed the land use suitability map. So here you can see some sort of analysis that lays the background of land use plan based on which the planners develop the land use plan. It is not always true that these kinds of analysis will be there. There are many plans where you cannot find these kinds of analysis. I'll show some of the more analysis that we can do in urban planning that is not being used in any part of Bangladesh, but these are some of the new ones. Especially the Rashtriya Development Authority has developed these kinds of plan. This is actually not yet published, prepared by the it is prepared by the consultant team, as it is a very vulnerable area to the earthquake. They developed these kinds of plan. For Dhaka, they used hydrological model. For Joshua Benapul Corridor project, they also used hydrological model likewise. For land use mapping, I am not talking about the land use analysis. I am talking about the land use mapping. Bangladesh is still using quite old technology, except one part. We usually start with the georeferenced Musa map. Then Musa map is the cadastral map. It was prepared in 1920s, between 1920s and 1930s. Then they use some sort of photogrammetric data to develop these kinds of base map. This photogrammetric data comes from the satellite and also from drone. And using this base map, the surveyors go to field and put some bookmarks type of numbers over here, and they use logbook to identify what is there and what addition need to be done and what attribute data basically. And when these three things are combined together, we are getting the updated physical feature survey map that is looks like this. Using this physical feature survey map, we can develop the land use map, existing land use map. We will talk about this one later. In our previous presentation, we have also seen many applications of transportation. Urban planners also use transportation data in many different ways, because land use transportation interaction essentially serves as the base of all kinds of urban plan along with the economy. So when we are talking about the transportation, it is basically demand and supply. So demand comes from the population and their socioeconomic data. So we collect these kinds of data, and supply is the remaining road data, the transport mode data, etc. and etc. Then we need a modeling technique that will combine the demand and supply. We use typically the 4-step model for forecasting or integrating these two. Transportation itself has become so important over the years for the urban planners and also for the geographers that geographic information system for transportation has become an individual field, and several kinds of softwares are available nowadays for GIS-T. Service infrastructure, we sometimes collect it from the primary sources from the field, and also we sometimes collect it from the relevant government organization. These infrastructure includes, but not limited to, the water and sewage system, community services like religious establishment, health and education institutes, parks, playgrounds, social services, so on and so forth. Waste management system is also there. We need to collect all these sorts of data for our decision making. Let's focus on the data source and technology a bit more, because perhaps it would be essential for us to identify this one and very much pertinent for our current workshop. As I have said, the technology, adoption of technology depends largely on its development. Since 1990s, Bangladeshi urban planning was totally dependent on cadastral map based on the plain table survey, which was developed between 1920s and 1930s. Then we started using RTK GPS and total station data between 1990s and 2005. Those who were from Bangladesh here, they would like to know that Rajshahi development plan, the first one, the Rajshahi development plan was totally developed based on the total station and RTK data. Then after 1990s, low resolution satellite image, basically Landsat data, got its popularity in Bangladesh. The first the Dhaka Metropolitan Development Plan that was developed using, it was a strategic plan. It was developed using the Landsat data. We have recently started using the high resolution satellite image, stereo satellite image, and also unmanned aerial system. For Kushtia master plan, we have totally used the unmanned aerial system for development of digitization and development of that map. Non-spatial data, we can collect it from different sources, but as I have said, that after development of the preparation of, or finishing the digitization process, we usually go to the field using the data or printed map and collect the data on the paper. We are not so digital still in Bangladesh. We have tried it. We tried to use different kinds of softwares like GIS Collector, Kobo Toolbox, Survey 123, Batch Geo, some of the softwares like this to collect those data. But unfortunately, it was not effective enough. It was not fruitful enough, and accuracy was questionable. That's why still we are dependent on these kinds of data, the manual collection of the secondary data. While talking about the potential, Bangladesh in urban planning field, so far we have not seen any application of LiDAR data. I am not saying that it is a issue from Bangladeshi part, but urban LiDAR to be used for UAV, which has to be very lightweight, range has to be pretty high, about 500 meters or so. These kinds of LiDAR has not been developed for quite long. It is a recent development. Multispectral and hyperspectral images that can be using the UAS is never used in Bangladesh. Well, in some cases we have used multispectral data, but hyperspectral data is almost unnoticeable in Bangladeshi urban planning. High resolution radar images, we don't see its application much. There are two other issues that we need to consider with utmost importance. Bangladeshi people often say that data is not available. It is actually not true. Data is available. It is only not available to the common people. So Bangladesh government has taken different kinds of initiatives. So far, I can see three initiatives. One is the National Spatial Data Infrastructure. You can find another one, Geodash, and BVS, Bangladesh Bureau of Statistics, has taken another initiative, BGISP. I'm a member of that BGISP, and you can find these kinds of initiatives are there, but I don't think that it is going to be fruitful enough, because most of these initiatives are project based, and you need a coordination and policy support, the legal support to establish these kinds of data sharing protocol. VR and AR is getting day by day more and more importance. We have seen some application of VR and AR, and we'll see more in the coming days. And of course, VR and AR is still in the developing stage. It is pretty mature, but still it is in the developing stage. Lastly, as I have said that I am apart from being an urban planner, I'm also an academician. This gives me an opportunity to criticize my work that I have done in the field and identify the gap between the academic practice and the practice that we see in the profession. So in doing so, what I am going to show you in next couple of slides, that what I want to point out is that their planners, professional planners, need to go ahead and take some more risk and use the GIS geospatial data, analyze it even more further, and incorporate it in the planning practice. Let's see some examples. Here in the left hand side, this is actually, I have used the Mongla master plan data, right hand side, sorry, the data. And here you can see the newly under construction coal-fired power plant at Rampal. Here, what I am showing in this circular shape is the spread of sulfur dioxide using the spatial Gaussian dispersion model. In the left hand side, I have shown the relationship between land surface temperature and the change of land use, land cover over the years. And in both the cases, you cannot see any of the application of the outcome of these researches in the planning, not in Khulna, not in Mongla. Here we have used different kinds of machine learning algorithm on the land use, land cover of Khulna city to predict the future. And this kind of land use, land cover prediction is very important for planning related decision making, where we essentially deals with the land use development for different kinds of development management. At the same time, the built environment, urban built environment is getting more and more attention nowadays. Livability is getting more and more attention nowadays. Here we have analyzed, and I have seen such application in my previous previous presentation. We have analyzed the shadow of different buildings for different kinds of setback. Setback is the place between the area boundary of an area and the building coverage. So if you increase the area of this land, then the shadow usually decreases, and the light, the people living in these areas usually get better lights. Here we have analyzed a section of a residential area where you can see that this is the height of different buildings. So 20-meter heights means there is no one building over 20-meter height, where we can see the interaction between the temperature and velocity of air. We need to identify these kinds, we need to analyze these kinds of analysis and show its reflection in the planning documents. These are some of the things. Please note that in no way my intention was not to provide. I'm well ahead of my time. If you have any question, I can answer later. Thank you very much.